Okay, ladies and gents, this is solving systems of equations by elimination. We did substitution last Friday. If you had issues with it, we'll have a couple days before your test, which is next Wednesday, the 4th, to ask questions. But you guys have already learned elimination and substitution. You started doing this, some of you probably end of your 8th grade year, definitely in Algebra 1. There's nothing new to it. It's the same concepts, just kind of building blocks of what we're about to do in 7-3. You will be able to use a calculator. You guys will have fractions. You will have decimals. I'll show you some shortcuts on how to get out of using fractions and decimals if you're not comfortable with it. But elimination. When you solve by using elimination, you're trying to get the coefficients, of x or y to be exact opposites of each other. Meaning -3, +3, -4, +4. You're going to have to multiply by different things. But in order to get them to cancel out when you add down, and then you just substitute back in. So if you have a question like this, solve the system of linear equations. I don't care. I'm not going to tell you what you have to solve for. Where you have to solve for x, solve for y. Do what is easier. So if you look at this set of systems, what is the easiest variable to get rid of?
2y.
The y's. Why are the y's easy to get rid of? They already cancel each other out. If you wanted to do x's, that's fine, but you can just cancel out the two y's. If I add down, what is 3x plus 5x?
8x.
8x. What happens to my positive 2, -2? Equals, what's 4 plus 8? 12. How do I get x by itself? Divide by 8. Good. So I get x equals 3/2. All right, sometimes we get a fraction, we immediately freak out, we don't like it. How can I write 3/2 as a decimal?
1.5.
Okay, it's the same as 1.5. I don't care. You guys can go back and forth from fractions to decimals, that's fine. If you start off with fractions in your problem, your answer should be in fraction form. If you start off in decimals, your answer should be in decimal form. This one doesn't start off in either, so it doesn't matter to me. Now that, now that I found my x value, how do I find the y? You just plug in the x into, does it matter? You can do either one. Does not matter. So I'm just going to say, okay, 3 times 1.5. Again, you could put 3/2 if you want to. Plus 2y equals 4. So 3 times 1.5 happens to be 4.5. Plus 2y equals 4. Subtract 4.5 from both sides, yes? Are you with me? 2y equals -0.5, and then what? Divide by 2. So y equals here -0.25. If I was going to keep it in fraction form, it would be -1/4. Everybody agree? Okay, so you found your solution to be, you could either write it as 3/2 -1/4, or you could write it as 1.5 -0.25. Everybody with me?
Yeah.
You need to check to make sure that your solution set satisfies both equations. Guys, it takes literally 2 seconds. You come up here and you say, okay, 3 times 1.5 plus 2 times -0.25. Does that equal 4? Well, 3 times 1.5 was 4.5. Minus 0.5, does it equal 4? Yes. So then I say, okay, 5 times 1.5 minus 2 times -0.25. Does that equal 8? This is 7.5 plus 0.5. Does that equal 8? Yes. So you're good to go. So either one of those, you could answer either way. Yes, ma'am?
Where did you get 8x equals 12?
Where did I get 8x equals 12? From this first step here. I added down my two equations, so 3 plus 5 is 8, and then the 2's cancel it out. No. So how many solutions does this problem have?
2.
No.
Or 1.
It only has one.
Sorry.
One solution. So that means if I graph these two lines, how many times would they cross? Once. You guys are going to be expected to graph on your web assigns and on your test. How do you graph a line? What kind of form does it have to be in? Slope intercepts, y equals mx plus b. If you guys don't know how to do that, you need to get on YouTube or Khan Academy and refresh your memory on how to graph a line. We're not going through that. All right, let's go to the next one. Here's my system. Is this set up as easy as the last one was?
No.
No. Again, some people want to eliminate x's, some will want to eliminate y's. It does not matter to me. Why do I think it's easier to eliminate y's in this one? Because one's negative, one's positive already. We don't have to worry about anything else. If you want to eliminate x's, fine, but let's eliminate the y's. What are we going to multiply by?
3.
Okay, so the top we're going to multiply by 4, and the bottom we're going to multiply by 3. Agreed? Yes or no?
Yes.
Okay, guys, remember when we do this, we distribute to everything. So 4 times 5 is 20x. 4 times 3 is 12y equals 4 times 9 is 36. You have to go to both sides of the equal sign. And then on the bottom, 3 times 2 is 6x. 3 times negative 4 is negative 12y. And 3 times 14 is 42.
This is elimination.
So now what happens? The 12s cancel out. So you have 26x equals 78. Now what? Divide both sides by 26. And x equals how much? 3. Now, once we know that x equals 3, excuse me, how do we find y? Plug it in. Doesn't matter where. Yes or no?
No.
No, I'm just going to plug it into the top one. So 5 times 3 plus 3y equals 9. 5 times 3 is 15 plus 3y equals 9 minus 15 from both sides, right? So 3y equals negative 6. Divide by 3. And y equals negative 2. So you found your solution point to be 3 comma negative 2. Guys, when I did this first period, I was rushing through and I made a sign error. And I came out with 3 comma 2. I could have just moved on and been like, okay, I'm fine. But I went back to check it and then I caught my mistake because there is a huge difference between 3 negative 2 and 3 positive 2. So just make sure you guys are checking. If we come back up here and check real quick, 5 times 3 plus 3 times negative 2, does that equal 9? Well, 5 times 3 is 15, yes? And 15 minus 6 is? 15 minus 6 is? 9, so you're good. In the bottom here, 2 times 3 minus 4 times negative 2, does that give me 14? 2 times 3 is 6, plus 8, is that 14?
Yes.
Yes, you're good to go. How many solutions does this set have? 1. We good? Okay, now we're going to talk about different kinds of solutions, and you guys will have this on your test, so make sure you understand. If you have exactly one solution, you'll get y equals something, x equals something. Your graph will intersect at one point. If you have like x squared plus y, your graph will intersect 2 places. Whatever the highest exponent is, how many solutions you could possibly have. If you have infinite many solutions, and I'll show you what that looks like algebraically, the lines are coincident. They coincide. They're on top of each other. So you would graph one of the lines, then you would graph the other line, and they're right on top of each other. That's what it means that they coincide. So any point along these 2 lines would satisfy both equations. That's infinite many. No solution is parallel lines. Parallel lines don't ever what? They don't ever touch. They don't ever intersect. So this is no solution graphically. And this is infinite, meaning there's an infinite amount of solutions. Everyone understand that? Okay? Just make sure so you don't come up to me and ask. All right, let's look at these 3 graphs. Just looking at the graphs, first one, second one, third one. There are 2 lines graphed in every single picture. So in the first picture, what is that? Infinite many solutions, 1 solution, or no solution?
Infinite many.
That's infinite many. How come?
Because the lines coincide.
Because the lines coincide. What about the second picture? No solution, because the lines never do what? They don't ever touch. And then what's the last one? Exactly 1 solution, because the lines touch at one point. So algebraically, if you figure that out, let's just look at A. Let's eliminate. What do you guys want to eliminate?
The 6.
The y's? Okay. What are you going to multiply the top by then?
2.
Okay. So if I multiply everything by 2, I'm going to write it underneath. I have 2. Oh, just kidding. 2 times 2 is 4x. 2 times 3, negative 3 is negative 6y. And 2 times 3 is 6. Agreed? Okay, so this is gone. So if I add down, what's negative 4x and positive 4x? 0. What's negative 6y and positive 6y?
0, 0.
Equals 12. So this statement says 0 equals 12.
No solution.
Correct. Is that true?
No.
That is not true. If someone owes you $12, they say, I'll just give you 0. It's the same thing. That is not true. So when you algebraically work out a system of equations and you get 0 equals a number or a number equals a different number, that's no solution. That means graphically, if you graph them, what would the graph look like to no solution?
Just be one. It'd be 2 lines, but.
It'll be parallel. They don't ever touch. So here in B, what do you guys want to eliminate with B?
There's 2x.
The x's? Okay, so you multiply the bottom by 2? Negative 2, good. So this will become negative 2x, negative 4y, and negative 10. Agreed?
Mm-hmm.
Okay, so this is gone. So if we add down, x's cancel out. You have negative 7y equals negative 7. Divide both sides by negative 7, so y equals 1, right? So what would you do with y equals 1?
You would plug it back in.
Plug it back in to get the x value, yes? So how many solutions is this going to have? 1. It'll have one solution. So it goes with which graph? With the third one, right? Where they cross one time. If you have a solution, you'll end up where one of your variables cancels out and you're solving for the other one. You can have y equals something, x equals something. I just don't want you guys to make mistakes on the easy part of this stuff. All right, let's look at the next one. What do you want to cancel out?
You can cancel out the x's.
X's? Okay, so if I multiply what? Top by 2?
Yeah.
So I'll have 4x minus 6y equals 6. What happens to my x's? Cancels out. What happens to y's?
Cancels out.
What happens to 6? Negative 6. Cancels out. When you have 0 equals 0 or 7 equals 7 or something like that, that's your infinite. So you guys need to be very careful with the types of solutions. When you work it out and the x's cancel out, you get y equals something, and then you plug it back in to find x. That's easy. But there's two situations that you guys, I don't want you to get confused. If it's a number equals a different number, like 0 equals 12, that's not true. So that's when it's no solution. When everything cancels out, then it's infinite many solutions. So when you graph it, it's the same line on top of each other. Does that make sense? Yes or no? Yeah. All right, couple things I'm going to bring to your attention before we do the last two examples. Just so you don't get hung up. If I asked you to solve this systems of equation, could you? Yeah. Can you do it how it is set up?
No.
No. Why not?
Because you have to make the variables. Like you have to make them the same.
They got to be lined up. Guys, you see how we should go alphabetically? You should go x's, then y's, equal sign, constant. Check that first on your WebAssign and on your test before you just go to solve. You'd be surprised how many people just go through this. They just treat them like they're the same variables because you're just not paying attention, and then you get it wrong. So make sure all variables are lined up, okay? Vertically. Lined up vertically. All right, another thing I want to bring to your attention. Some of us don't like fractions or decimals. So if you have a systems of equations and it says to solve it, and it's like 0.25x plus 0.35y equals 4. And you guys are like, oh, I just don't want to work with decimals. Can I do something to get rid of all of the decimals?
You can make it a fraction.
I could make it a fraction, you're right. What else could I do?
Move the decimal.
Correct. If I move this decimal point over 2 places, can I move this decimal? Then I'd have to move this one over 2. And then what? This one over 2. I just multiplied by 100. So this would become 25x plus 35y equals 400. If you do that every time you have a decimal, that is perfectly fine. Just whatever you do to one term, you have to do to every single term. So if you multiply something to move the decimal 2 places, then you have to multiply every decimal point 2 places. That make sense? All right, another thing. If we hate fractions, 1/3 x plus 1/2 y equals 5. What's 5 over? 1, okay? Some of us are like, oh my gosh, I don't want to use fractions. That's fine. Guys, get rid of the denominators. What's a common denominator between 3, 2, and 1? 6. So watch, if I were to multiply this whole thing by 6, what's 6 divided by 3? So this would be 2x plus what?
Plus 3y.
3y equals 30. And now you have whole numbers. I do not mind if you do that. If you want to work with the fractions, that's fine. But if I were you, just so you don't make mistakes, I would make the process as easy as possible. Sound good? All right, let's look at these last 2 and then we're done. Solve the system of linear equations. What do you guys want to get rid of first?
Multiply the top by 2.
Okay, you want to get rid of the x's?
Yeah.
Okay. So multiply the whole top by 2. So it's 2x minus 4y equals 6. When I add down, what's negative 2 and positive 2?
0.
0. What's negative 4 and positive 4?
0.
Equals
7.
7. Does 0 ever in life equal 7?
No.
No solution. If you were to graph these 2 lines,
They would be parallel.
graphically, these would be what, Franco? Good. I don't think I spelled parallel right. That's okay, though. All right, let's look at the last one. What do you want to get rid of?
Multiply the top by -2.
Top by negative 2. Okay. So we have negative 4x plus 2y equals negative 2. 4x and negative 4x, 0. Negative 2y, positive 2y, 0. Positive 2, negative 2.
0.
What happens when everything cancels out? Infinite solutions. That means they are what kind of lines?
They're perpendicular.
Not
They're
perpendicular.
the same line.
It's the same line. You would graph and they'd be right on top of each other, meaning any point in the world that's on those lines will satisfy both equations. So you're going to be asked on your test to solve using substitution, elimination. You're going to have to graph, all stuff that you guys have seen before. 7.3 is a little more in depth, but nothing you guys can't handle, I promise. We good?